Good evening. This is the relearning for the second standard on the conservation of momentum test. Before we get started on any problems, we have a few key definitions you need to write down on your worksheet. First, you should write down the law of conservation of momentum. The momentum of an object will not change unless an outside force acts upon it. And momentum is an object's resistance to slowing, stopping, or speeding up. The two parts of momentum are mass and time. Momentum equals mass times time. And then Newton's third law, for every force, there is an equal and opposite force. This means forces in a collision are always equal. If you need more time, please just go ahead and pause the video at this point. Now, one key thing to remember, there was a question on the test that said, if a football is falling through the air, speeding up as it goes, and it's gaining momentum, is it breaking the laws of physics? And the answer is no. Laws of physics cannot be broken. So violate, again, I think was the word that was used on the test. Violate means to break. So if you're falling from a treehouse, you're continuously gaining momentum because you're speeding up as you fall to the ground. Does it violate the law of conservation of momentum? The answer is no. So why? Is because what is pulling on us? If you're falling, there is an outside force, and that outside force is gravity. Something is slowing down as it rolls across the ground. There's probably friction acting on it. So eventually it's going to stop. Again, it doesn't say it can never change. It's not going to change unless an outside force acts on it. And if that outside force could be gravity or friction or applied force, anytime the momentum is changing, it's because there's an outside force acting on it. So the answer, if the question is asking, is it being broken? Is this law being broken? The answer for sure is no. And then we have to make sure we understand why. Now, going back to the law of conservation of momentum, we have to see when two things collide, their momentum gets added up. Now, if their direction is opposite, you're going to label one as positive direction and one as negative, or one as positive momentum and one as negative, and then they would cancel out. So you basically are subtracting the two momentums to find the total new momentum. Same direction momentums will add because they should have the same sign because they're going in the same direction. So the question then is, how do we solve these multi-step problems? That was another issue for us. So first you need to use your equations to calculate the original momentums. Next, you need to find your total masses, so add the two masses of the things that are colliding. Third, you're going to find the total momentum. So if one object is not moving, the total momentum is going to be the original momentum of the moving object. If both of them are moving in opposite directions, you're going to find the difference. Now, the nice thing for you guys is this is a higher level question. And so what I'm doing for you is I'm going to spell out the steps. The big thing you need to know is that if you see the word difference, you need to know that you're going to subtract. You're going to also use the total momentum and the total mass then. Once you've calculated these, then you need to calculate the new speed. So let's do some practice. So I'm going to go to our worksheet, and I don't have it printed off. Usually I'll have it printed off. I will say, I'm guessing I am going to put a space in your worksheet for you to write down those steps. So these will probably change in their number, but I'll see if I can keep them the same. I haven't actually printed it out yet. So we're going to look at number 4 first. A train car is moving at 4 meters per second. And it's going to stick to another train car of the same mass. Now this is a little different than the problems I described in the slideshow. But we need to realize that the total momentum is going to stay the same. And so if the original mass is m, times the original v, and that equals p for our momentum. And if we double the mass when the two train cars run into each other, the only way for this to stay p is for the velocity to be cut in half. So the answer for number 4 is the speed or velocity is half the original speed. If this algebra description doesn't make sense to you, you can just memorize if two things are running into each other and they have the same mass, their speed has to get cut in half. Looking at number 5, number 5 says a teacher runs into her student. Picture me running into one of my students. The student has a smaller mass. Which force is larger, the teacher running into the student or the student running into the teacher? Forces are always equal. So they are equal. Neither force is larger. Number 6 is going to give us these, we're going to get us into these calculation problems. And before we go, I'm going to just take a minute and I would suggest you write these down as well. Momentum, remember P is momentum, equals mass times velocity. Mass equals momentum divided by velocity. And velocity equals momentum divided by mass. Now remember, momentum is not a real thing. We're just calling it that in order to help us remember that P means momentum. All right, so number 6. Number 6 says, if a fully loaded shopping cart with a mass of 100 kilograms moving at 5 meters per second runs into an empty, not moving shopping cart with a mass of 20 kilograms, what is their new speed? Now you notice they didn't leave any space because our last part is going to answer the original question. You're not answering this question yet. So A says, what's the momentum of the full shopping cart before the collision? So A is momentum equals mass times velocity. And I'm going to list what I know. And I don't know momentum. I do know the mass of the cart is 100 kilograms, and I do know the velocity of the cart is 5 meters per second. So momentum equals 100 kilograms times 5 meters per second. And so our momentum is 500 kilogram meters per second. So that's the first part of the question. What is the new mass once they run into each other? If you look back on the steps, you find mass equals the mass of the fully loaded one plus the mass of the empty one. And that equals 120 kilograms. Letter C, what's their new speed? Speed equals momentum divided by mass. Oh, we have a momentum here, 500 kilogram meters per second divided by 120 kilograms. And I'm gonna go ahead and just speed up the process. Divide 150 by 120. We can round to the nearest tenth. So 4.2. And we gotta look back. Our kilograms cancel out, so our unit is 4.2 meters per second. And that's the speed of the shopping cart. Let's look at number 7. Number 7, two football players run into each other. The first, number 88, was moving 5 meters per second from left to right. 5 meters per second. 88. And has a mass of 50 kilograms. The second, number 45, was moving 3 meters per second. Sorry about my units there, got a little sloppy. And has a mass of 75 kilograms. How fast were they moving once they collide? So same thing, we're going to do it piece by piece. So what's the momentum of 88 before the collision? So momentum equals mass times velocity. We're looking at number 88. So we got 50 kilograms times 5 meters per second. 50 kilograms times 5 meters per second equals 250 kilogram meters per second. Letter B, ask what the momentum of number 45 before the collision. Momentum equals mass times velocity, which equals 75 kilograms times 3. 75 kilograms times 3 meters per second. If you want to use your calculator, you can, but I'm just going to say, okay, well, 75 times 2 would be 150 plus another 75. That gives us 225 kilogram meters per second. So, see, what's the difference between the two momentums? Only 50 kilogram meters per second. Letter D, so difference is subtraction, so I've subtracted 250 and 225. D, what's the total mass? Mass equals 50 plus 75, kg plus 75, kg, equals 125 kilograms. And then E, if I scroll down, asks what is their new speed after the crash. The big thing here, and the most common issue I saw on the test, was you guys tried to like subtract speed. Can't do that. You got to calculate it. So you got to use this momentum, the difference in the momentum, 50 kilogram meters per second divided by 125 kilograms, which is their total mass. And again, if my brain was less tired, I can know that 50 divided by 125 is 0.4, but it's not, and I'm going to cheat. And that's our final speed. And it's going to be going in the direction of from left to right, the direction of number 88. All right, I hope this was helpful. Please let me know if you need more assistance. There'll be a retest. Please do some more practice. I will check them to make sure that you know what's going on. Thanks very much and have a great day. Good luck with the rest of the worksheet.